Alright, so I know it's been a while since I've done a video, but I've been pretty busy with school, it's not enough time to make any videos, but I logged back on my account and I saw that I was still getting subscribers even though I haven't submitted a video in months. And I read some of the comments and a lot of them were encouraging. Some of them, had some constructive feedback, but I felt bad for not keeping up with my videos. But I promise you now I'm going to make a conscious effort to probably upload a video at least once a week. So just to get back into it, I thought I'd start off with oxidation numbers and just going over it because it's pretty simple and a short topic. So oxidation numbers, basically these numbers are a way to keep track of electrons when a reaction happens. And before you can get into the reactions, you need to know how to look at a compound or element and know what its oxidation number is. So here that I have written to the left are the oxidation number rules on how to tell what oxidation state the atom or molecule is in. And I already wrote it out for you, so you don't have to watch me writing it out. That was one of the complaints I saw in one of the comments. There was too much stylus, so I wrote it out for you. And I know it looks kind of weird and different color coded and you're wondering what's going on, but I'm going to go over each single rule and give you examples. It's actually really simple. If you can count and memorize 7 things, then this is going to be real easy for you. So we're going to start off with rule number 1, which is a very easy rule. Free elements have an oxidation number of 0. Alright, so for example, for a free element would be an element that's standing by itself, like hydrogen gas, H2. So the oxidation number of both of those hydrogens, because there's 2 of them, is going to be 0. Pretty easy, right? Let's do another one. How about if we did Br2, another free element by itself. So both oxidation numbers of both bromines are going to be 0. So rule number 1, very, very easy. Rule number 2 is just as easy. The ions, the oxidation number of ions equals the charge of that ion. So if I wrote this right here, calcium 2 plus, the oxidation number of that is 2 plus, is 2. Very easy. I mean, just in case, I'll throw another one on there. How about iron 3 plus, oxidation number of that is 3. Okay, so rule number 1, rule number 2, very easy. Rule number 3, okay, this is where it gets a little tricky, but it's still not even that bad. Rule number 3 is oxygen has an oxidation number of -2. So all you have to do is memorize oxygen, -2. But there are some exceptions. Okay, I know you're probably rolling your eyes now, but it's not too bad. So hydrogen peroxide and this oxygen molecule right here, which is called peroxide ion, the oxygen in these molecules have an oxidation number of -1. And you really don't come across these very often. So if you want to, you could just memorize oxygen, -2, and if you have time, you should make time, memorize these exceptions. Okay, so oxygen, -2. I don't really have to write an example. Well, okay, well, just for you guys. Actually, I'll do an example after the next rule. So, rule number 4 is hydrogen is +1. So just like rule number 3 where you had to memorize, same thing with rule number 4. Hydrogen is +1. The exceptions are metal binary compounds where it is -1. Okay, so for example, metal binary compound would be one like, oops, didn't mean to do that. Here we go. Lithium and hydrogen. So the oxidation number of hydrogen in this compound, because it's with a metal, would be -1. Alright, so really, once again, just memorize hydrogen is +1, and there are just a few exceptions when hydrogen's bounded with a metal in a binary compound. Now, an example for the oxygen and the hydrogen, if you take water for example, okay? So the oxidation number, if you're trying to figure out the oxidation numbers of each element, remember I said oxygen is -2, so that, let's do a different color. So this color will be the oxidation number. Oxygen is -2, and the hydrogen, because of rule number 4, is +1. And remember, there's 2 hydrogens there. So very easy, rule 1 through 4 so far. Alright, let's check out rule number 5. Halogens are -1. Okay, just like rule 3 and 4, you just got to memorize halogens are -1. The only exceptions are if you put chloride, bromide, or iodine with oxygen. If these halogens are bound to an oxygen, then their oxidation numbers are positive. So I don't really need to show an example for that. The main thing you really need to know is halogens are -1. Alright, now rule number 6. This is the tricky one right here. This is probably the most difficult rule, but I'm telling you it is very, very simple. I mean, it's just simple algebra when it comes to it. So, rule number 6, and like I said, it's important. That's why I put a circle around it. In a molecule, the sum of the individual oxidation numbers equals the overall charge. Okay, so what exactly does that mean? You know, I just actually did the same exact thing with this example right here, but I'm going to do it again, just so it's simple. Okay, so, you know what, let's, I can't erase that. Okay, so let's take, oops, meant to do a different color. Alright, let me just scroll down a little. Okay, so we're on rule number 6. Once again, we take water molecule. Alright, so what is the overall charge of this water molecule? The overall charge, we'll make that in green, is 0. Because if there's a charge, it would be in this area as a superscript right here. But if there's no number, that means it's neutral. So the overall charge of the water molecule is 0. Now, if we follow this rule again, in a molecule, the sum of the individual oxidation numbers equals the overall charge. So let's make this as a algebra equation. Okay, so if we do, we'll put an equal sign here. Okay, so in a molecule, the sum of the individual oxidation numbers, so that means the oxidation number of hydrogen, we'll put that as H, and there's 2 of them, so I'm going to put times 2, plus the oxidation number of oxygen, so I'll put a O right there. Don't mistake that for 0, equals the overall charge of the molecule, which is 0 because it's a neutral. So equals 0, and I'll put a line through it as 0. So this, once again, this is very easy. So in a molecule, the sum of the individual oxidation numbers, the hydrogen times 2 because there's 2 of them, plus the oxygen, there's only 1 oxygen, equals 0 because it's a neutral molecule. So now, all we have to do is figure it out. So what is the oxidation number of hydrogen? According to rule number 1, it is 1. Alright, times 2, because there's 2 of them. Put that in parentheses. Plus the oxidation number of oxygen, which is -2, according to rule number 3. I'll put that in parentheses to make it look nice. Equals 0. Okay, so if you work that out, 1 times 2 is 2, plus -2 equals 0. So that is exactly what rule number 6 means. And that is a very simple example. Let me do a more complicated one. Okay, so let's move down again. Let's do ammonium. Yeah. Plus. Okay, so this one's a little more complicated. And say you got this problem. They said, figure out the oxidation number of all the elements in the compound. And you can immediately say, according to rule number 4, hydrogen is plus. And they're like, alright, what about the nitrogen? And none of the rules tell you what nitrogen is. So you're like, oh man. So what you have to use is rule number 6. Alright? So once again, the sum of the individual oxidation numbers in the molecule equals the overall charge. So that means the oxidation number of nitrogen plus the oxidation number of hydrogen times 4, because there's 4 of them, equals, and this one has a charge, it's plus, so equals +1. Alright, so let's see if we can figure this out. Once again, it's just simple algebra. The oxidation number of nitrogen, we have no idea what it is. So we're just going to leave it as N, plus the oxidation number of hydrogen, which is 1, times 4, equals +1. Alright, so now if you guys have taken algebra, there's only one variable, so easy to figure out. Nitrogen plus 4 equals +1. So you subtract 4 from both sides. Nitrogen equals -3. Very simple. So now we just figured out the oxidation number of nitrogen for the ammonium molecule up here is -3, and the oxidation number of the individual hydrogens is +1. Oh, about to write 4. Hold on. Okay, apparently I forgot how this program works, but you get the idea. Nitrogen is -3. The oxidation number of hydrogen is +1. Remember, individual hydrogens, and there's 4 in there. So there's 4 hydrogens with an oxidation number of +1. So the last rule is not really a rule, it's just kind of a statement. Just remember, oxidation numbers don't have to be integers. So they can be, it's not necessarily 1, 2, 3, 4, or 5. It can be a half or 2/3 or so on. So these are the rules for figuring out oxidation numbers. They're very simple. I mean, like I said, the first 2 are very, very easy. The rest are just really small memorizations, a few exceptions, not a big idea, not really big. But rule number 6, that's the important one. But once again, that one is very easy too. So maybe in another video we'll figure out how to use these oxidation numbers in redox reactions. So if you enjoyed the video, give it a like or leave a comment, and please, if this video helped you at all, please share with other people so you can help them too.